In the last issue, we talked about the first two parts of this series, LoRa physical layer technology and LoRaWAN protocol. In this issue, we will talk about the remaining LoRa network planning and deployment, LoRa application cases, and LoRa network planning and LoRa security and privacy protection and deployment. The planning and deployment of LoRa networks need to consider 5 aspects including gateway placement, gateway coverage, channel configuration, network capacity, and reliability in actual application scenarios. 1. The layout of LoRa gateways needs to be considered from the geographical environment, gateway density, and how to place the gateway antennas. First of all, the geographical environment is an important factor affecting the LoRa network. In urban environments, gateways should be placed in high-rise buildings or open areas to obtain the best line of sight and reduce signal attenuation caused by building obstructions. For rural or remote areas, it may be necessary to increase the number of gateways to expand gateway coverage and ensure that each node can successfully access the LoRa network. Secondly, the density of gateways has a greater impact on network quality. The density of gateway deployment is determined based on the expected number of terminal devices and data transmission requirements. When deploying a gateway, it is recommended that the signal coverage between gateways overlap to a certain extent. When the signal of a certain gateway is not good, the node is allowed to switch the connected gateway to ensure the stability of the network. In addition, more gateways can provide greater network capacity and redundancy, thereby ensuring network stability and service quality. Finally, the placement of the antenna is also particular. Appropriate antenna gain and installation angle can help improve receiving sensitivity and expand coverage radius. It is generally recommended to place the antenna high and perpendicular to the ground. If a directional antenna is used, you need to install it according to the direction and angle of the antenna. 2. Since there will be environmental interference noise in the on-site environment, the signal coverage of the gateway cannot reach the distance tested in the laboratory, so the coverage of the gateway needs to be planned. Planning the scope of the gateway is generally divided into 2 steps. First, based on the characteristics of LoRa technology, the link budget for the actual coverage of each gateway is calculated, and factors such as transmit power, receiving sensitivity, antenna gain, and path loss need to be included in the calculation within. After obtaining the simulation prediction results of the radio frequency planning tool, it is necessary to accurately adjust the location and number of gateways in conjunction with on-site signal strength testing to ensure that there are no blind spots in the target area and maintain good signal quality. 3. Carry out frequency planning within the licensed frequency band to avoid co-channel interference. For example, in China, LoRa networks need to work within the designated 470 MHz to 510 MHz or 779 MHz to 787 MHz frequency bands. In the case of high-density deployment, different channels should be reasonably allocated between different gateways to avoid interference between the same channels. In addition, it is also necessary to select appropriate SF and BW according to the actual distance and throughput requirements. A reasonable configuration should take into account the needs of long-distance low-speed transmission and short-distance high-speed transmission. 4. In terms of network capacity, for large-scale deployment, a hierarchical network can be used, which means dividing subnets or a multi-level network structure to distribute different types of equipment or services on different channels and gateways to reduce network congestion. Risk. Using the adaptive data rate (ADR) mechanism in LoRaWAN, the transmission parameters of the terminal device can be automatically adjusted to balance network capacity and energy consumption efficiency. Finally, air interface access control can be used to optimize network utilization in the presence of large numbers of concurrent transmissions. 5. For the security of LoRa network, it is necessary to ensure that all devices comply with LoRaWAN security specifications and implement measures such as network authentication, encrypted transmission, and prevention of man-in-the-middle attacks. In addition, in critical applications, to ensure service continuity, you should consider deploying backup gateways and perform failover and load balancing designs at the network level. Next, we analyze a case to explain in detail how to deploy the LoRa network. In a relatively vast grassland, it is necessary to set up weather stations to collect meteorological data from different locations on the grassland. This scenario is a scenario where multiple sensors transmit data to an application, so a star or mesh network topology is chosen. Since the grassland is relatively vast, the interference of environmental noise on the signal is relatively small. At the same time, if the antenna is raised, a single gateway is enough to cover the detection equipment in a larger area. Multiple nodes may send data concurrently and frequently, so choose to use the air interface. Access control to optimize network utilization. In addition, add several more gateways within the scope of the deployed gateways. When a problem occurs with a gateway, the node can switch the connected network by itself, making the data transmission more stable and increasing the robustness of the network.